Welcome to the DevOps and CI-CD practice series from the AI Mock Interviewer Question Bank. DevOps and CI-CD Part 1. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. CI or CD or GitOps? Argo CD drift. A team says Argo CD shows drift between Git and the cluster. How would you investigate and safely reconcile it? Here's a strong way to approach it. Check the Argo CD diff view to see exactly what's different between the Git declared state and the live cluster state, and determine whether the drift came from a manual kubectl change, a mutating webhook or controller modifying the resource after Argo CD applied it, or a genuine intended change that wasn't committed to Git yet. If it's an unauthorized manual change, sync to reconcile back to Git state. If it's a legitimate change, commit it to Git first so Git remains the source of truth, rather than just clicking sync and losing the change. Nice. Let's continue. Question 2. Terraform or IAC? Terraform monorepo versus multi-repo. How would you decide repository structure for Terraform modules, environments, and app teams? Here's a strong way to approach it. Use a monorepo for shared modules where you want atomic changes and easy discoverability across the platform team, but keep environment or team-specific configurations in separate repos or clearly separated directories with independent state, so one team's apply can't accidentally affect another's infrastructure. The key factor is blast radius and ownership boundaries. Structure repos so a given team's changes are isolated to what they actually own, regardless of whether that's technically one repo or many. Great. Moving on. Question 3. Security or DevSecOps? Secrets rotation. How would you rotate secrets or keys for production services without downtime? Here's a strong way to approach it. Use a rotation pattern that supports both old and new credentials being valid simultaneously for a transition window. Create the new secret version. Deploy it to consumers. Verify they've picked it up. Check logs or metrics for successful auth with the new version. Then revoke the old version only after confirming the cutover succeeded. Never revoke the old secret before verifying the new one works. And automate this pattern. Secret manager versioning plus a rollout or verify or revoke pipeline. So rotation is routine rather than a risky manual event. Alright, next question. Question 4. Observability. Prometheus scale. Prometheus is overloaded with high cardinality metrics. How would you debug and fix it? Here's a strong way to approach it. Identify the highest cardinality metrics using top queries against Prometheus's own Prometheus TSDB metrics or a cardinality analysis tool, and look for label values that shouldn't be labels at all, like user IDs or full URLs, which explode series count. Fix it by removing or aggregating high cardinality labels at the source, using recording rules to pre-aggregate frequently queried expensive metrics, and considering a remote write or Thanos or Cortex setup to shard load if a single Prometheus instance genuinely can't handle the required scale. Let's keep going. Question 5. GKE or Kubernetes? Capacity planning. How would you design capacity planning for GKE node pools supporting both web services and batch or ML workloads? Here's a strong way to approach it. Separate node pools by workload type. Web services on pools tuned for steady, predictable request-driven scaling, and batch or ML on pools that can use spot or preemptible instances and scale aggressively down to zero when idle. Since their utilization patterns and cost sensitivity differ significantly, forecast capacity from historical peak usage plus growth trends per pool independently, and ensure batch or ML workloads can't starve web services of node capacity by using separate quotas or priority classes. On to the next one. Question 6. Automation or platform? Pipeline orchestration. Compare Airflow, Dagster, Kubeflow, and Vertex AI pipelines for ML or platform use cases. How would you choose? Here's a strong way to approach it. Airflow is the general purpose, widely adopted choice for orchestrating any scheduled workflow, not ML specific, with a huge ecosystem of integrations. Dagster offers a more modern, asset-based approach with better local development and testing ergonomics. Kubeflow Pipelines is Kubernetes native and well-suited when your ML infrastructure is already Kubernetes-centric. Vertex AI Pipelines is the fully managed GCP option with tight integration into Vertex AI's model registry and monitoring, trading some flexibility for lower operational overhead. Choose based on how much of your stack is already GCP managed versus needing portability. Good. Here's another one. Question 7. CI or CD or GitOps. Cloud build. How would you design cloud build pipelines for Docker builds, vulnerability scanning, provenance, tests, and deployment promotion? Here's a strong way to approach it. Structure the pipeline as sequential steps. Run tests first. Fail fast before spending time on a build. Build the Docker image with BuildKit for caching efficiency. Scan it for vulnerabilities and block on critical findings. Generate build provenance or attestation and sign the image. Then push to artifact registry. Use separate cloud build triggers per environment so promotion to staging or production is an explicit, reviewable step. Updating a deployment manifest reference, rather than the same pipeline auto-deploying everywhere. Nice. Let's continue. Question 8. Terraform or IAC. Organization policy. Which GCP org policies would you enforce for a secure baseline, and how would you handle exceptions? Here's a strong way to approach it. Enforce policies like disabling service account key creation, favor workload identity, restricting public IP assignment on VMs, requiring OS login, restricting resource locations for compliance, and enabling public access prevention on storage by default. Handle exceptions through a lightweight, documented request process with an expiry or review date rather than a permanent blanket override, so exceptions stay visible and don't quietly become the new normal. Great. Moving on. Question 9. Security or DevSecOps. Supply chain security. How would you implement image scanning, provenance, binary authorization, SBOMs, and deployment policies for containers? Here's a strong way to approach it. Scan every image for vulnerabilities at build time and continuously in the registry. Generate an SBOM, software bill of materials as part of the build so you know exactly what's in each image. And produce signed build provenance attesting to the source commit and build system. Configure binary authorization to reject any image at deploy time that isn't signed by your trusted CI pipeline with valid attestations, closing the gap where someone could otherwise push and run an unverified image directly. Alright, next question. Question 10. GKE or Kubernetes. Container startup. A container works locally but fails in Kubernetes. How would you debug entry point, NVVARs, file system, permissions, and security context? Here's a strong way to approach it. Check kubectl describe pod and kubectl logs first for the exact failure reason, then verify all environment variables or config maps or secrets referenced in the pod spec are actually present. A common gap versus local Docker run where you might pass a local.env file. Check whether the pod's security context, run as non-root, read-only root file system is causing a permission failure the local run didn't have, and confirm the entry point command doesn't assume an interactive TDY or a working directory that doesn't exist in the Kubernetes provided file system. Let's keep going. Question 11. Terraform or IAC. Terraform Enterprise. Explain how you would implement Terraform Enterprise workspaces, remote state, policy as code, approvals, and module versioning for a large GCP platform. Here's a strong way to approach it. Structure workspaces per environment or team with clear naming conventions. Use Terraform Enterprise's built-in remote state management with access controls per workspace, and enforce Sentinel policies, or OPA, that validate plans against organizational guardrails before allowing apply. Require approval workflows on production workspaces so a plan must be reviewed before apply executes, and publish shared modules to the private registry with semantic versioning so teams consume tested, versioned infrastructure code rather than copy-pasting Terraform. On to the next one. Question 12. Networking. Hybrid connectivity. A service is slow over VPN or interconnect. How would you troubleshoot latency, MTU, routes, BGP, firewall rules, and DNS? Here's a strong way to approach it. Measure baseline latency and packet loss over the connection first to establish whether it's a genuine network problem or an application level issue. Then check for MTU-related fragmentation, Large packets failing while small ones succeed is a classic sign. And verify BGP routes are advertising and being learned correctly if using dynamic routing. Confirm firewall rules aren't introducing extra hops or being hit inefficiently. And check DNS resolution time separately from data plane latency, since a slow DNS lookup can masquerade as general connection slowness. Good. Here's another one. Question 13. CI/CD or GitOps, Backstage and IDP. How would you design a backstage-style golden path for creating a new service on GCP with CI/CD, Terraform, monitoring, and security? Here's a strong way to approach it. Build a software template that scaffolds a new service repository with a working CI/CD pipeline. Pre-configured Terraform module calls for the standard infrastructure, GKE deployment, monitoring dashboards, IAM, and baseline security controls already wired in, so a developer running the template gets a production-ready starting point in minutes. Register the resulting service automatically in the catalog with ownership metadata, and keep the template itself versioned so it can improve over time without breaking services already scaffolded from an earlier version. Nice. Let's continue. That wraps up this episode. Nice work practicing, and see you in the next one.